Okay, so last week we were able to get our rag up and going in Mastra. So far we have just been writing the code and we're able to get the full rag thing in place. Um, Starting from the first phase, which is the ingestion phase. And the ingestion phase is made up of four main steps. The first step is loading the document. And there are many different documents. So always remember that when you're doing rags, you always have to remember that you have different documents. What I'm actually doing here is what we call a naive rag, which is you're not really we are not really going to the depths of it, right? Just basics. But you find that when you start building a rag in a real world situation, you have a lot of challenges, right? We're not really talking about those challenges here. Things like, for example, um, incomplete documents, documents that have errors and things like that, or even the fact that sometimes chunking issues, sometimes documents may not be in entirely text format, especially non-text format documents. Documents that mix up different formats, like PDF documents that have tables in them, images, um, sections and all of that. So there's a lot, of things I have to deal with in this phase of loading and then chunking. So loading is the first step, chunking is the second step. Then you embed the chunks, right? Using any embedding model so that you get the vector embeddings. And then you put in those vector embeddings into the vector store, which is a fourth step, right? You create a vector store and then you insert. In most cases, the vector store typically would have been created and it's available running in memory. And then it's only the index should have also been created. So these two will be done outside of a regular API call. You are not going to create vector store or index each time your endpoint is called, right? This will be done ahead. It's only the offsets that you would do. The offset goes with the embed and all of that. So these ones are part of the request cycle, right? The ingestion, or already the loading, chunking, embedding, and then offset. Those are actually the four steps. This one is only done once anyway. Then when you want to retrieve, in other words, you now have a user that types in a query that you want to retrieve the documents that kind of match that query semantically. Then this is the second phase, and this one just has two steps. The first step is you take the prompt, you embed the prompt. So in embedding the prompt, the embedding has a semantic value. That's what embeddings are basically, a representation of the meaning in, the query or prompts that you typed. So then you do a query, a search in the vector store to find other things that match it, semantically, basically looking at the meaning, not just the words or the letters. So it's as simple as that. Of course, when you are doing the query, you can decide whether you want to use cosine similarity or something, right? Here, when in this case, when you are creating the vector store, is when you decide the semantic matching. Maybe this is a default, but typically you can also decide to choose a different approach, right? And that's it. So the next thing would be creating an agent that can then query this rag. So we did this here. We created an agent and we give the agent instruction. The instruction is basically the system um, prompt, and then you pass in the tool. So this tool has to be a tool that can um, do the actual querying. We didn't do that yet, so I'm going to now essentially extract this. So at this point, we can begin to be a bit more realistic and pull things out. So I'm going to create a whole rag, you know, module here, and then I'll move all the rag stuff in there. So, um, so in here we had, this is the whole rag section. So I'm going to move all of this here and then structure it so that you can even have the tool available. Now, what we just did here should all be in a function, right? So I'm going to split we will split this section. Remember the one, this is the section we said you only do it um once, you know, we can create a constant to hold it. For example, we can just create something here and say vector store, right? We just create a variable, then we have now initialize vector store, right? So then we can put in all of the stuff we just copied, which is basically going to be um so this should be two, right. So since we already had vector store here, we don't need to declare it here. So we just do this, then we'll import the libsql vector from here. And then what else? M documents. So we get the M document as well. From Mastra's rag module. Embed me from AI, we're using that as well. Plugin face, we're using that as well. So that's the main thing. We have this. So and we can also just return the vector store, just alternatively, we could even not keep it global. Instead, we yeah, so I'm here to decide whether it should be kept globally or returned from this. So let's just leave it global for now. So that's the phase where you initialize. Then this is the phase where you do a um um query rag or query vector store, right? So and then you have the query. So we're going to have all of this. Oh, sorry. Before this, we'll still need to do the ingestion phase. So now have const ingest document. So ingest document will take the ingestion phase, which is the whole of phase one, right? Which has to be these 4 steps. All right. Yeah, um so we don't need to, so this is the document. We can call this raw document. So the raw document, we will load it. So we can assume that this raw document is a string, or let me just say string document. Now, if it is HTML, we could do another variant for HTML, right? If we have, since we have Markdown, JSON, and all of that, so we could even just call it document. And then this will be a string. And then we could also have type, right? Which, yeah, we'll go with that. So it's either text HTML, Markdown, or JSON. And the Copilot is doing double time. So if it is text, then use from text. which is what we had before. If it is HTML, you use from HTML. If it is Markdown, you use from Markdown. If it is JSON, use from JSON. And we don't need an else because we've already used TypeScript's type control to make sure that you cannot pass in something that's not in any of those. Okay. So we can take these ones off. So we now do chunking. Chunking is basically same thing. Then we do embedding, right? And yeah, and then we do the offset. So the offset we can pass in the vector store, or we can use this one that has been specified, right? So I'll just leave it as it is for now, and then we can close this. Okay. So vector store implicitly has any type. So to query, of course, the query is this last part of it, which is the retrieval. Okay. And we can call this prompt, type is string, and that's what we use. So again, vector store, we can take vector store that we have here. Now, because of the typing thing, I have to specify the type of vector store here. And well, it shouldn't be lib SQL vector because lib SQL vector is a subtype. So let's see, it is actually a Mastra vector, right? So a Mastra vector, we can use that. Let me see where I'll import that from. So it's from Mastra core vector. So I assume that the generic type for vector stores. Yeah, so this will be a Mastra vector. So that solved that problem. Embeddings. Okay, so embeddings, oh yeah, so here this is assuming that we already knew the embedding size. But one way to do this is that you can just do an embedding, a sample embedding, right? So what you could do here is make this a variable. You pass it in so that you can be sure. Embedding model, right? We can just call it embedding model. And we'll pass that in here as well. So embedding model, and then we can give a default value. So let me split this up a bit. Type. Again, we can find the proper correct type for this, right? It shouldn't be any. Okay. Uh, yeah, so here we should also be able to have embedding. All right, and we could use some defaults. Maybe defaults are good sometimes. So here we can specify a default and say something like if embedding model is that. Yeah, so that allows us to have a default value. So when we are doing this It is that embedding model that we use. We embed it, and we use that as the sample. So you can do a sample embedding of any test value, and from there you take the length. So that way you don't need to worry too much about that. So it's always a good idea to pass in the embedding model. One thing I could do is um, we should also return the embedding model as part of the return values, so that this is very helpful, so that if nothing was passed in, at least you get back embedding that was used, because this same embedding has to be used for when you are doing. Alternatively, if you did this whole thing like a class, which is not what I'm doing here anyway, we could do the whole RAG as a it's typically a good idea to do it that way, so that you can it can be stateful, it can store values like the embedding model and things like that. Okay, so that's another way of handling it. Okay, that way you even just create a single instance of it, right? So I think that's a good idea. I'll come and do that quickly. Um, then the embedding model here, we would have just used the existing embedding model. Okay, so let's use a class object-oriented approach. Yeah, I think we can use that approach. Let's see. So that's probably the best way to do this. So let's create a class, and in this case, we don't need this vector store to be outside. We can just create a class and call it rag, right? Um, let's just call it rag plus rag. Okay, so it will have a constructor as usual. So we are going to pass in, we can either pass in embedding model and vector store, right? Or so we can pass in the vector store. Mm, all right, so we can pass in any of these two. And then, um, so here, the good thing with this is um, we can do a new lib SQL vector store, and that, so we initialize, if we initialize what we want, if the vector store is not created. As a matter of fact, when you're using this kind of setup, the best option is actually to put it in the constructor, so that you force the user or the developer that is using this class, or yourself, if it is yourself, you force yourself to do the right thing, right? So yeah, so the vector store is created by basically initializing it this way. I think I would even prefer, well, I would say private. This basically means this is the initializer already. But yeah, we'll leave it that way. Okay. Okay. So with that, we don't need this. In the constructor, we can as well create the index in the constructor as well. So um This vector store create index. So we dimension. Yeah, so last time we had to do all of this, so we can still do that with this. That way we don't need any of this anymore. Um, we already have embedding model. So you do the embedding and then you get the dimension from the embedding. Okay, right. So what this means is that constructor also has to be um constructor may have to be um we can make this into if we cannot await could do this then we use it then chain. We could just do this, all right? So instead of awaiting, we just do then and the only thing is that we have to cascade this across. All right. Um, so this is typically how you pass this across, but now it's possibly no. Um, that's interesting. I don't know why it says it's possibly no, but we could use that. Okay, the vector store that is possibly no. So I did not need to do this. But I think I prefer rag. So if the vector store is no, okay, so that is your constructor. So at this point, you should be able to have your vector store, your embedding model, and then you do the embed, and then when you get the embedding, you use that. So this is just like not having to guess the embedding size. Okay, so with that, we don't need to initialize because our constructor has initialized. So the next thing is to add the necessary functions. So the first function would be ingest document, which is basically what we have here. So this is an async function. I'll just take this whole thing and put it in. So it's actually much better when it is object oriented. And then we will pass the documents in. Um, so it should be an async function. And we can indent this properly. And then I'll clean up the rest of it. So specify the document, return type annotation. You can come back to that embedding model. So now we don't need to pass in the embedding model anymore because you already have the embedding model in here. And I think that's the beauty of using an object-oriented, approach. So we now actually have the vector store, right? And you have the vector store, you have the embedding model, so you can update them. Ideally, this should actually be an if statement, right? So that you don't need to run this in a normal constructor. So it should actually be if the vector store doesn't exist, then you do this. Yeah. But you don't need to do this again because this already you know, this already initializes it. Same thing with embedding model. Right. That's really all you need. Okay. Okay. So, yeah. So we've done the constructor, and after that, we now do the embed, and then we initialize to create the index. Can give it any name, right? Or if the user wants to specify the name of the index, you can also add that as a constructor argument. Mm. But that's not really, we can make those choices, right? Let's not dwell on that. Okay. Now the ingest document, you have document type. So we did this already. And yeah, so there is a possibility that document um doesn't have a value, right? So I would maybe raise an exception here, okay, in order to allow logic to work properly. I would just say throw new error, exactly. So that way this doesn't have to happen. You know that there will always be doc. If you won't get into a place where there is no doc. Okay. So then you do the chunking, then embedding. So you take that this embedding model, yes, and that's what you use for chunking. Then also for this vector store, that's what you use for chunking. Ideally, also, even though we have said that vector store can be null, but you could also throw an exception here if vector store is not provided. But it's always good for robust coding for you to don't fail silently. That's a bad design. Always fail loudly. Let everyone know that something is wrong. Okay. All right. So now that is the we'll now do the query function. So the query function is going to be an async again. So can just say query vector store. Yeah. Or query, whatever. The prompt. Everything else just comes straight from what we already have. Okay, so this is a retrieval phase. You take the prompt, you embed the prompt from the embedding model value. You now do the vector store query, right? You already have the vector store, and you return the value, right? So in this case now, we're just going to return the results. Typically, these results are like the what they call the top N. Okay, so you return that, and that's the end of your class. You can specify return values here, but I think this is good enough. So we have a RAG class that we can easily use. Okay, now let's go back. Um, so we are back to our original class. Okay, we don't need all of this anymore. But now the SQL vector, we don't really need it. We needed it for RAG. Even though you could also need it for semantic memory. So if you wanted to do memory, right? So I'm going to pull things out here so that this section becomes easy to get. So we've pulled out the RAG. Now we can pull out the memory. So, but it's not really that hard. That memory is not a very complicated stuff, right? It's not a very complicated stuff. So I'll just leave it as it is. Okay. So we can have agents, right? So let's move agents also out to another a separate file which we can bring in. We can call it agents. So here, this allows you to put in as many agents as you want. Right. So we can have a RAG agent. So let's make a RAG agent now. So the name is RAG agent retrieval augmented generation. It can retrieve. So this instructions. This is a system prompt. Okay. This you are an agent that has access to internal um, information in a RAG system. So use the RAG tool. So here I'm just making this agent just for RAG, but you could actually just make this agent. Let's make a general agent first, right? Instead of just a specific RAG agent. Let's just call it agent. Okay, agent one. Okay. So to create an agent, of course, we have to import the whole agent thing here. And right. Okay, so memory, if we want to add memory, we can add yeah, let's add memory at once. Even though I did not create a memory folder, but let's add some tools. So we could create a RAG tool here. So agents are usually at the top of everything. Let's create a tools folder, a tools module rather, and then we can move the tools there as well. So you put the tools in the tool. So we have one tool here, so we can create a RAG tool here. Right, the RAG tool now needs me to import RAG. Import RAG from ./RAG. Okay, so we import RAG. I can't remember what we called it. Okay, we did not export it, so export class. So it doesn't know about this because I didn't export it. So now it knows about it, and we can import create tool, Mastra core tools, and we can import Zod. Zod. Okay. All right. So the RAG tool would be RAG tool equals create tool. So we specify it as RAG tool. This is a RAG tool input schema. The prompts that you want, and the output schema is the string, which will be like the response. But actually, RAG tool is not going to be the response. The the output schema should actually be retrieve results. I would prefer the results to come as a structured, anyway, let's leave it this way because I think this is also a good way of passing it into the agent. But yeah, okay. So we have a RAG tool. We have this other tool which doesn't really do much. So we have a tool, we have a RAG tool. Then so we can go to the agent. We can now import the RAG tool. Right, and then so in tools here we'll put RAG tool. Memory. So let's take memory out for now. We'll come back to memory. Okay, so I didn't remember to export the tools. So we can export the tools here. Okay. So in the agents we now have RAG tool. So we have agent one. So here in the index, if we want an agent, we can pull it in. All right. Now the next thing is workflow. So we had a workflow which we just, we had placed it in here. So I'm just going to also extract it to make it easier. So I'll create workflows.ts. So the workflow is going to basically contain the steps in the workflow, and you can essentially create any number of workflows that you want, including the dynamic workflows. Okay, so I'm going to delete this RAG agent off. I'll come back to it. Okay, so we have workflows here. Typically, it's always good to put this in a function, right? Um, it's always a good idea to put in a function, but this is a static workflow, so we can just create it right here, right off the bat. And then we will export it so that we can have access to it. Okay, we don't need to export the steps. Steps are all inside the workflow itself. So yeah, let me move this agent there just to be sure that I did not miss anything. Okay, there was a RAG agent, but I'm not going to do the RAG agent yet. When I get to agent orchestration, then we'll do the RAG agent. But for now, I think we have everything. This is RAG prompt. So the RAG prompt is what we will use when we are creating the well, okay, that was the benefit of using for a RAG agent, you would need to have this prompt, right? Um, you you can also just not have to give this agent a RAG prompt. But let me just keep this here. Let me just drop this here. You don't really need to give this agent um you know a RAG prompt. But then when later on you see that when you're orchestrating agents, it may be a good idea to have some agents that are specialized. So you may actually have an agent that specializes on RAG. But right now we're not doing that. We're just having an agent that has access to a RAG tool. So from the RAG tool, it knows it can so let's just use a generic system prompt. Say you are a helpful um, assistant. Then you can add something. For example, you have tools to help you uh, to answer queries, right? Then we could also add the RAG prompt here. Use the retrieve information to answer user queries. Okay, so that's still good enough, right? To at least tell the LLM, you know, that it can actually use the RAG tool and it should be able to use the RAG tool. And the RAG tool, which you have put on that tools, you actually put a description to say this is a RAG tool. So um, you can have a better description. This is not a very good description. Something like use this tool to, or something much better than that. Something more descriptive. So remember when you're talking about prompts, your prompts have to be very expressive to tell the description is actually can be considered as a prompt because you're essentially telling the LLM when it is inspecting the metadata for this tool, you are telling it what it can do with the tool. Okay. So the RAG tool basically creates a new RAG and then does this. Ideally, I would not create a new RAG every time. So this wasn't properly done. Ideally, you would maybe you create for something like RAG, you want to create what we call an a singleton, right? Create a single RAG that you initialize and we will reuse that RAG. Okay, so we can actually put it here and say, okay, singleton is you can export it as well. And so the the benefit of this is that as long as you use this RAG, it will use the same vector store and the same embedding model, even if it is using these default ones. Otherwise, it will end up creating new ones all the time. Even though if you create a vector store from the same file, it will always do the same thing. And if you create this a same embedding model, right, it will always give you the same, answer back. But there's still some overhead cost of having to keep recreating a new one each time. So maybe sometimes it's good for you to keep a singleton. So the tool doesn't need to create a new rag each time. It will just use the singleton rag, which will be imported correctly from here. So you actually importing singleton rag, and yeah, so you just query the vector store. Um, yeah, so that's it. Um, there's one last thing with rag. Of course, you have to do ingestion. So you have to give it data. So what we can do here is to create a data folder, and maybe we can just put in some data here. So all the documents. I'm going to take this out of the public folder. It shouldn't have been a public folder. So I'll take it out and I'll put it in source Mastra. Okay. So any documents that you want to ingest will be ingested from here, even though we did not yet do any ingestion, right? But we can start off by trying to ingest something. Um, okay, now we have memory. I could have taken this out to a new, a separate memory, you know, file, or we can leave it in here. All right, so we have agents. Yeah, let's take it out. Let's take out the memory. So what is now remaining is for us to do the workspace. Um, okay, so we have to import memory from Mastra memory. Not Mastra core memories, Mastra memory. Then we have to import lib SQL store from Mastra. Then we have to export the memory. Now, because we have the same ID, we're using the same ID and the same memory file, right? So these are just relative paths. We'll see them scattered all over here. So I'm not trying to do too much. Okay. So so what is left is the master the .m config. We can then import stuff. Ideally, config should come before if you have to bring in or any access to the .env, which agents starts first, unless you are making agents into a function. So that's where um, you know, it's good to put them in a function. So here we could just do something like let's create a function, sport constant get agents, and we just get all the agents. Okay, so we get all the agents basically. Um, let me just do this. So we have agent one, then we can have any other number of agents that we want to have, agent two, and so on. So we can then just return the agents I want to return. And that's it. So get agents will give us all the agents, and then we can take the one that we want. So that way, it allows us to import before. We can import everything else before and import config last. All right. We can also do the same thing with workflows. So agent one, we get agent one. Um, yeah, let's just get agent one. We have to run config first so that the .env file becomes available to where we are getting the agent. And then we can do anything we like. So because we've done all of that scaffolding, right? Now, the next thing I want us to look at is workspaces, right? So we'll kind of continue. Um, so a workspace is basically simply done this way. And you specify a workspace, and then you specify the things that should be in that workspace. So let's create, yeah, let's just create a file for workspaces in the same spirit, right? We could actually have done the workspace here as well. Um, or let's do this, let's do the workspace here. Let's do the workspace here. So we will import workspaces from Mastra. I don't know if we will import it directly. Import workspace from Mastra core workspace. So we already did that. So to now create a workspace is basically workspace. You can call it any name. So in a workspace, you give it an ID. Then you there are other things. I want to be sure what else. Um you can then add a lot of other stuff, right? So for example, you can add agents, okay? You can add workflows. So at least let us start with this very basic stuff, right? So workspace doesn't have description, it just has ID and name. Um Workspace file system workspace sandbox. So I think the interface for workspaces has changed. Um, yeah, before you could just put agents in workspace, put in workflows. Okay, so let's look at what is in the latest documentation for workspaces. And we're going to talk about workflows as well. Um, so we have the configuration is workspace config. So we're going to check the workspace config and let's see what workspace config gives to us. The workspace config has ID name provider and instructions. Okay, so the workspace basically has changed. It's no more what it was. Before you could just go and agent in there. But now, um, you have to, you can't do that anymore. Workspace basically is used to set up a file system. So what I was going to do now in Workspace is what you now do in Mastra itself. We'll come to that. So let's talk about the server. We'll come back to the workspace, but the workspace is a configuration. Okay. Um, so let's do a server. So the server is going to be just a server. It's not going to server. Well, we can just inline it. Can inline it. Typically, server is specify server configuration. You specify the port number and all of that. But let's just inline it in the master definition. So this is now the master instance. In the master instance, you specify the agent. So right now we have agent one. We have workflow. Let's see the workflow we have. Workflow. Yeah, okay. Workflow one. We have workflow one. So right now we have agent. Then we can add a logger. Uh, um, Loggers are good. There is what they call a final logger, which is um, it's very useful, very simple to set up. So that's a master call logger. This has changed as well. Probably taking it out into oh, okay. Okay, I think the problem is not that they've taken it out. Problem is that I have not installed it. Okay, so I have to install it. npm install Mastra loggers. Okay. All right, so that will resolve that. So they have that. The other thing they have is um okay, that has installed, so it's good to go. Um, so the other thing you will have, so let's talk a little bit about observability. I know we talked about observability, but the question was, what is even observability, right? So let's just do very basic observability. So they also have an observability um, entry here when you're setting up the Mastra Studio, where you specify observability, and you can specify a lot of additional. Now I'm basically checking their stuff. So you can configure a whole lot of stuff here, right? But let's just start with configs, con config. Oh, I missed something. We have to create the observability um, instance, right? And the observability instance is imported from Mastra observability. So they also have that. And you also have to install that. npm install Mastra observability. Okay. So yeah, so that has been installed. So you bring in a new observability, then you can put in all the things I was talking about. Configs. So configs are the configurations that you want to give. Um, let's start with a simple one. Um, we may need a bit more time to talk about observability, but normally just specify maybe like a default, your default observability tool or provider, right? You specify the service name, right? And then the exporter. So exporter is um, kind of um, what you will use to export whatever um, traces, logs, or metrics that you know um, you have, right? So there are different kinds of exporters. Um, there's a default exporter. Uh, there is a console which you can import again from Mastra observability. Even though the default exporter, from what I'm seeing here now, it looks like it is now obsolete. So there's a console. Let's see if there's a console exporter. There's a console exporter as well. So yeah, so default exporter is crossed out, meaning it's deprecated. If you look at it, they probably are going to recommend a different one. So let's use Mastra storage exporter, right? So you can use Mastra storage exporter. So let's use that Mastra storage exporter. Then we can also use a console exporter. So the whole idea is exporters are things that would take the traces and export them into a format that you can read. And there are many different kinds of exporters. So the whole idea of observability is a totally different subject entirely, right? Especially when you're talking about something like open telemetry and so on. Okay, so we've set up a new Mastra instance. Basically, we've added one agent, we've added one workflow, we've added a logger, we've added observability. Okay, now one last thing you want to add is a server. So remember, we're talking about servers. The server is what will now allow you to connect. So you can specify a port. So here we'll use standard port 3000. Host, now on this, I don't know, I think I should use 0.0.0.0 so that because I'm in a code space, it will be easier to work with. Then I will also handle course so that you have, so origin is that means allow all origins. It could either be this or that. Then we also have allow methods, allow methods. So allow methods is which methods you allow. So you can allow all of them. Allow headers. Well, okay. So this is a master instance. We have set up the server. We have set up observability logger workflows. One other thing I did not specify was storage. So we can also set up storage as well at this level. We did storage with libsql store when we were talking about memory, right? So the interesting thing is that you can also still use libsql store for you can also use libsql store for the general storage of everything else here. All right. Okay, so with all of this, I think I have set up everything. I've set up a tool as a RAG tool. Even though the RAG tool, I've not put in any documents, I've not uploaded any documents. So I'm not going to try to test that. Um, but now what we just need to do is let's try it. So to try, of course, you will run the Mastra instance. Okay. To run the Mastra instance, we run npm npx um, Mastra, if I am not wrong. Okay, so dev. Yeah, I forgot. Should be npx Mastra dev for the console, for the Mastra Studio. So one thing we have done, yes, we have set up a server. Now, the interesting thing is that when you set up a server with Mastra, everything that you put in that Mastra instance becomes accessible. For example, the agent, right? How do we access this agent? Okay, so they have routing that allows you to access the agent. And so you can directly query the agent. Well, let's see. No such model. So sentence transformers, all mini LM L6 V2. I can't remember if I did this. Okay, this should be Hugging Face. So where we are creating the RAG, I needed to specify um okay. So it's saying no such model error is not able to. I need to go and check. Um yeah, I need to go and check. I probably didn't this normally works with Python and LangChain, but it's probably different for Mastra. So I'm going to check that. But for now, what I will do, therefore, is to essentially take out the RAG tool, which is unfortunate, completely. And let's see if it rebuilds. Okay, so it's rebuilt, and you can now see that the studio, um, well, studio is now on 3000, which is interesting. I actually thought um, that would be the server. Okay, so I have to specify this as the and then remove this API prefix API. So is you going to use the API as API prefix? Right. Now, because take note of the API prefix, I'm going to now see if I can access that API prefix, which is API, right? And you see that you basically have Mastra API with Swagger. So we can now go to Swagger. This is now because we have set up the server. Um, okay, so the redirect is a problem. So let me now redirect. I think that needs to be fixed. We'll just do Swagger UI on the so you can see that we have a Swagger UI. and you can see agents. So the agents that we have in that agents, the agents that we put in here in this, if you go to index, the Mastra instance, you see where we put in the list of the agents, right? So all the agents that you put in here are accessible. And how you access them in Swagger is by specifying, or via the API, how you access them is by specifying the agent ID. And then you can get all kinds of things. You can do speak, you can do skills, you can do listen. You can, of course, at the top, it starts with the very basic capability of agents, right? Generate and stream. So you can actually call this and let me see if I may. So let's see if we just do generate just basic generation. Okay. It's a bit slow. So the question you may be asking is, what is the agent ID that I will use? The agent ID you would use will be the ID you specify when you created the agent. So if we look at where we created the agent, the ID we used was agent-1. So this is the ID you will use to access that agent from Swagger. I think I have to refresh this. It has somehow crashed. So this same agent, we can also access it from here, the RAG agent. The workflows, we also have a workflow. Now, the interesting thing is, let's talk about observability a little bit. You can now go in, it says metrics are now available with current storage because I basically, so I may have to get the storage provider doesn't support metric aggregation. So you can go and change that. Um, I probably need to do libsql, right, or in-memory storage, right? Um, so logs, yeah. So let's go switch to libsql, but I think I thought I had libsql storage, but it didn't give me that. Um, let's go back and do that. Um, so where we are defining the, I hope I've not run out of, I hope I've not run out of space in my, slowing down. They have so many endpoints in Swagger. Swagger alone is just going crazy. Okay, so if we want to get an agent by ID, um, yeah, it's pretty heavy. That's what I'm seeing here. So Swagger is already going crazy. You could also use Postman, right? Um, let's see if I use Postman. I will use Postman, and I will use Postman. So I have Postman instance here. Um, Okay. Well, this came up finally. All right. So agent ID, let me see if this will work. So agent ID is agent one. And well, so let's just run this and see what we get. So you get information on the agent, all of the stuff that we had here, including the model ID. By the way, this model ID was failing at some point. Okay, so we can then try to generate content from that agent by using the generate endpoint. Um, yeah, again, this takes time. We're already having failure. Storage provider does not support service name discovery. So the storage provider I used, maybe because I did not specify a storage provider for observability, I actually thought this Lips SQL store should have been enough for it. But let's see if I can add a storage provider here. Um, oh, this is not working. Um, let's see. So um, typically you add a storage provider when you are setting up the uh, okay, I'll come back to that. So let's try and see if you want to then communicate with this agent, you specify the agent ID. So that was agent one. And then you can send your normal messages. Um, what is the um, meaning of purpose? I think I'll take away all of these other ones. It's a whole lot of stuff here, which you probably don't need all of this, right? But um, let's just send only the messages, just like when we're simplifying for Langsef. And let's see if this will give us something. Okay, so I get a 500, but it says user not found. Um, that's interesting. Okay, so user not found actually comes from the API back end. It comes from the open router because I basically did not specify. Um, I need to specify an API key for it. So because Mastra allows you to set up your agents and then specify. So let's do that properly. Where I created agent one, open router, NVIDIA. So that's okay. So I need to get the API key. So let me do that quickly. I'm going to do an API key. The last one I did has obviously expired, which is what I did in the last class. So let me do another one, but I'll do it behind the scenes so that the API key does not show up here. And I'm again going to just do an API key that will last for just one day. So that's the reason why we're having that user not found. Interestingly, if you don't handle your exception properly, that's what users will see, and they'll think that user not found means the account doesn't exist, when the actual issue is that it is the API key that has not been tied to an existing user. In other words, the API key has expired. That's not a very good, to be honest, not a very good response from Open Router. But then again, as a developer, you are expected to handle that at the point of making that, um, you know, at the point of making that query, you're supposed to handle that, or making that API call is supposed to handle that, so that it doesn't come up. Okay, so this one has expired, obviously, and this is a new one, which of course is going to expire. Yeah, so it has reloaded. Let us make that call again and see what we get this time. So now we are calling from the API because we have attached a server. But one other thing, yeah, so we now get a response from it. But one other thing that I think has changed so is that even when you don't specify a server configuration, Mastra Studio is going to still spin up a server and give you the port number 4111, right? And so you can still access the API through that server. So effectively, Mastra already provides you an API endpoint that allows you to access all of the agents. So you can see there's a whole lot of stuff here. Can't go through all of it, but you can go and check it out, right? If you want to update the agent model, order, then you can also check the tools that the agent has and get the skills the agent has, right? Basically, a whole gamut of stuff. This allows you to really interact with your agents. So all you need to really worry about is creating it, not building scaffolding around how you would use the agent, or how you troubleshoot the agent while you are improving it. Remember, one of the things that you find for yourself generally as an AI developer is most of your work will eventually revolve around two things, I would say: prompts and tools. How well can you write prompts for your agents, and how well can you build tools that will give your agents a lot of capability? So let's see if I can. We could have done the RAG, but I don't have a lot of time. But maybe you can take that as a take home to go figure out. The only issue was the Hugging Face. For some reason, the sentence transformers. I guess the main reason is that sentence transformers requires to be downloaded. So that's not the one that Mastra is connecting to. Mastra is connecting to the API version of the Hugging Face embedding model, which is not sentence transformers. So I needed to go and check that in Hugging Face and check it or change it. Okay, so that's basically how you can set up everything. We've looked at everything, workflows. Um, we looked at tools, RAG, memory. right? And the interesting thing is that you can also still interact with your agent directly as prosecutor. You can still directly interact with your agent here. So you don't even need to do the API calls. Now, um, the rest of this is going to be about, okay, how do we connect our Next.js, for example, to it, right? By the way, this is still the same agent one, as you can see, agent one. So the Master Studio is still using the same API endpoint to connect to the agent, right? What is the meaning of purpose? Um, yeah, so the good thing here is you can also see tools and so on. So you really don't need, if you are trying to um, play with your agents, try to improve it, try to tweak it, right? It takes away a lot of the challenge from you. You can do it yourself. Now let's see if we can get these metrics to show up. To get the metrics, I need to switch and put in a storage that is either relational database or in-memory storage, like libsql or MS SQL. So let's see how we can do that so that we can see a bit of the um, observability. Um, I'm just surprised because I had put in storage here. That is SQL storage. So let me double check it. We we have put storage here. That is the SQL store, right? And this should have been enough for observability, but for some reason we are not. Let me see if it even created my storage DB file. So we have my memory DB. This one was created as part of the memory that we gave to the agent, which you see under memory TS. That's the my memory DB file here, which you know that was created. That's why the agent is able to even have a recall. But now we're talking about storage for observability. Typically, you would put it in that um, data structure for observability. So let's try out, see. Um, Top level observability as observability as config. Default has configs. Observability. Um, uh, so we could set logger. We already had logger. We could set logger, but that is see, zero storage. That's okay. Um, let's see if I put it in here. Um, provider storage. So it's not here. Um, yeah, this is the let me take out this master storage button and see. Okay, so I'm going to check it out and then we'll look at it when we come back. Um, so we'll finish off with the observability. We'll try out a few things on the yeah, so it's you not working with this. Observability is kind of a bit of an advanced topic. So I feel like um, maybe I should take some time to look into it in depth. So I'll do that next week. Um, because after Mastra, we don't really have much else except to just build your front end and connect to the back end. But observability is sufficiently important that I think we should take some time to look into it. So I'll see how we can do that next week. So, but let's just round up with a few slides on advanced Mastra. So we've already now talked about the workspaces. We've talked about how you use workspaces. So what we actually had as workspace before is now the Mastra instance, the Mastra Studio. Now, what Mastra is calling workspace is the configuration of the workspace itself. So, for example, the files system and things like that. So we can look at that next week. We've already looked at the Mastra server, right? So the workspace and the Mastra server were basically collapsed into um, what we now see as the Mastra Studio. Um, yeah, we're going to take time and really look at observability in depth next week. What is observability and um, how can we realize it? Of course, I already showed us Langsmith, which does the same thing. But the question you'll be asking as a developer, what am I using observability for? How do I even use it? Then evals. So we'll do all of that next week. But one of the things I would like us to look at, um, just quickly go through the additional capabilities of Mastra. We've only touched just the basic stuff, which is we can create um, we can create agents, we can create workspaces, um, you know, we can create workflows rather than workspaces. We can create workflows, we can create memory and attach the agent and all of that. But that's not where it ends. There's a lot of additional stuff that you can do with Mastra, and I'm just going to take us quickly through some of the basic stuff that you can do with Mastra. Some of the basic stuff you can do with Mastra. Um, so there's something we call agent orchestration, agent routing. So far, we have been doing LLM routing, right? With LLM routing, we basically are able to decide which LLM we want to use, right? Which LLM provider we want to use for some specific task, or maybe not even, it may not even be based on specific task, but it may just be based on the fact that um, I don't have, I want to manage costs, or I want to manage, you know, I want to manage my um, um, uptime, if I may put it that way, reliability, right? And all of that kind of stuff. So we may not um, we may not realize that you can actually do much, much more than that. So I want to bring this up so that we can see um, what we call multi-agent orchestration. So multi-agent orchestration is something that Mastra gives, which is typically when you're doing a single agent, like what we just did, you just do a single agent. So your user sends a request, one agent gets it, and then you have two calls, right? Um, so this is good. This is simplistic. But you now find that there comes a time when um, there are the entire workflow or the things you have to do are so complex and there are so many. You really cannot squeeze it into one agent to do everything. Um, the things to do are varied. Maybe the prompts you have to do are varied. Maybe the tools. Well, it's not really about the tools, because if it were about the tools, that one agent can decide to select which tool is the right one. But in some situations, you actually need to specialize agents. You need to, even to a point of fine-tuning the agents, the LLM itself. But other things like fine-tuning prompts, right? Fine-tuning behavior, right? And in some situations, you may want, again, in the interest of things like managing costs, managing, um, you know, um, response time or latency and all of that. For more complex tasks, you may want to give a much larger LLM, an agent that has that. But for other, easier tasks that require speed, you may decide to do another agent. So we now have this slightly, or not slightly, it's a totally new, different architecture, right? In this case, it's what we call a multi-agent orchestration, or what we call agent-to-agent systems. So you hear of A to A. There is even a protocol now for agents to communicate. But in a multi-agent orchestration system, you have a single agent that doesn't really do much else apart from interacting with the user and then deciding which of the specialized agent is the best fit to handle the user's problem or task or query. That is a multi-agent. So this router agent is the one that is orchestrating all the other agents. The specialized agents, there will be a lot of them. And then, each of them have specialized tools, specialized prompts, tuned prompts, and other things, memory, and all kinds of other things, right? So, the main task of the router agent would be to figure out what to do. So this is kind of a good example of it, where you see that you have a router agent, which is just standard create agent, but its own system prompt or instruction is to decide which agent should take up the task, right? Then you still create other agents that are specialized. So for example, I was mentioning when I was talking about RAG, you could have actually a single agent that is specialized with answering questions from RAG. Okay, so you have a RAG tweet, maybe you have a knowledge base Maybe you may have internet browsing capability, ability to fetch a URL. So the task of that particular agent is it is optimized to find information, right? You could also have another agent, its own is to handle payments, invoices, refunds. And then you could have another agent, its own task is optimized to handle troubleshooting. You find that this becomes necessary because as you begin to build agents for specific tasks, you find that the fine-tuning you have to do for an agent for a specific task is so much. If you now change it and maybe switch, for example, the prompt itself that you would fine tune. If you now have to change it and maybe do something else, right? For that, it will not do very well if you give it a different task. Okay. So Mastra supports that model routing, um, agent routing. Of course, it also supports model routing, which is what we have already seen. Model routing is where you don't need to hard code um, the model name anymore, right? But you can dynamically come up with rules for it to decide which model to send the particular request, right? So that's one other thing it does. So there is agent routing, which is what I just talked about. You have specialized agents, then you have an orchestrating agent or a routing agent that will route. Then there is model routing. The model routing is where the LLM providers, right? You are able to switch to the one that gives the best performance at the best time or the best cost, at a particular time, right? Then Mastra also supports structured, what we call structured output. So you can specify the schema that you want the agent to always return. In other words, if you specify a schema, like in this case, again, we're using Zod to define the output schema, that the output should always come in this shape, a JSON with category, right? And urgency as a number, category as a string. Then you find that this schema that you specify when you are defining the agent and you specify the output is this output schema, it will force the LLM to always send its response in this shape, right? And we've already said structured output is a very key element for your AI agents to be able to integrate easily with existing code, existing software, existing tooling, that are non-AI so that they can communicate with those. Okay. So just this means that you don't need to stress yourself with JSON parsing, JSON correction, and all of that, right? It also gives you safer tool invocation. And it's also friendly with the backend because the backend also is looking for structured data. Okay. So that's the other thing that it does. Then the other things that Mastra has, it has middleware and interceptors. So there are actually hooks that you can hook your code into before the model is called, after the model is called, before it starts streaming, after it starts streaming, so that you can inject events or listen to those events and do a few things, right? Maybe preparatory or cleanup kind of things. So the use cases would be, for example, logging, cost tracking, which is actually very, very key. Cost tracking is important if you are providing a service that others will use, right? You need to track how much um, of the capability or of your resources that they are using so you can build them properly. P2 masking. So P2 has to do with privacy. Um, there's data that should be private that should not go to the LLM, right? people's names, people's social security numbers, account numbers, ID, personal private information typically should not be sent out. Even if for some reason the agent were to mistakenly or the user were to mistakenly provide such information in the prompt, right? P2 masking should remove and redact private information before that information goes um, to the API, to the AI API, right? So that's the other thing you could do in a before streaming or a before model call. Before model call, you make sure you check. And when you P2 masking is actually a standard. So even LangChain, Mastra, they have um, classes that you can just use and they will automatically detect. You can specify what they should be looking for and they will extract or redact. Moderation is essentially ensuring that the model does not return abusive or offensive information, right? Or, that's moderation basically. So moderation typically will come, after the model call before streaming, right? The response from the model, you can pass it through a moderation layer that will check and maybe can cross out things that shouldn't be there. Analytics. So these are some of the things you can do with middleware. Then we also have memory plugins. We already saw a bit of memory plugins, which we quickly did. But Mastra supports a lot of additional memory plugins. We saw the libsql Lite. Redis also has a memory plugin. Other databases, MongoDB, and so on. External storage mechanisms, including AWS, S3, and so on, right? And then you can even create your own custom memory backends. So, of course, what this enables for you when you are building your application is that you can store memory and conversation for much longer. You can retrieve them, you know, um, long after those conversations happened. You can have personalization, user selections, user settings, user preferences. Even preferences that are mentioned in the course of the conversation can be extracted and then stored so that later on, the same user, when the user comes back on, the agent knows the user's preferences and doesn't need to go do what the user doesn't want or what the user had already said that they don't like. That's what makes intelligence, that's what intelligence means, basically. Remembering what people have said, oh, I don't like this, or I don't like that. And then when you come back, it says, okay, I recall the last time we had this conversation, you said that you didn't like this, right? So, and then enterprise grade state. So what we mean by enterprise grade state is maintaining state, you know, whenever we talk about enterprise grade, that means at scale, right? So maintaining state at scale, keeping track of a lot of things. Yeah, so workflows, we've already talked about workflows. Mastra is not only chat. You can create a multi-step workflows. You can use it for data processing pipelines. You can use it for AI-powered document workflows, a whole lot of stuff, right? You can even just set up a workflow for um, ingestion, upload a document, extract text, summarize it, classify it, and store, right? So workflows give you a lot of power, essentially to chain predetermined, sequences of actions, right? As opposed to the dynamic sequence of actions that is not predetermined. You can also do background jobs, right? So background jobs come with master as well. So instead of you having to block chat, doing other stuff, you can delegate some heavy stuff. For example, generating reports, running a heavy tool, fetching external data, notifications, and so on. You can delegate to a background job while the main thread is still responsive and available for the conversation. And when the background job is done, you also get a notification and then you can also notify the user, right? So that improves the user experience a lot because you don't have blocking UX. It also enables enterprise integrations because it means at the back end, you can be doing stuff right in the background threads. It also enables task orchestration because it means you can deploy sub agents, right, to be running tasks in the background while the routing agent or the main agent is still engaging with the user. And user can keep doing other things. When the sub agent is done, the sub agent notifies the main agent is done, and then the main agent brings that result to the user. So that's another thing that Mastra allows you to do. Then there is a state machine, which is controlled reasoning, basically, right? Think of it as um, designing how the agent should think, right? Or the steps the agent should follow. Kind of think of it like instructions or directives or examples, right? Of how it should do things. So you can minimize hallucination and misuse of the LLM. So that's basically it. And interestingly, these principles apply not just to Mastra, but they also apply to others as well, including LangChain, right? Basically, it is saying that we have moved away from just basic agentic systems where, all you did was you have a user, the agent calls the LLM, right? For whatever information or whatever response. And it was that simple. But then, of course, life is not always simple. So we try to get better. Things are actually more complex than what we see. We always start with simple systems, right? But after that, we try to make the simple systems become more capable in to do complex things, right? So we now move from basic user to agent to LLM, right? We now move to user to agent to LLM to tools, which is the second step. And then now we have moved to a more thorough, more capable, more scalable architecture where you have users going to not just directly an agent, but an agentic router. And then the agentic router can then reach out and decide which agent should actually do, what the user has asked it to do, right? And then we now add observability as well. So observability means you can actually see what the agent is doing while it is doing it. And we'll do a deep dive into observability a little bit. We'll talk about open telemetry, talk about the three elements of observability. What do they mean? How do you even set it up, in your system? And how do you build it up? Um, how do you use existing tools for observability? Okay, so essentially, this is what I was talking about. If you had just one big agent to do everything, the biggest challenge you would have would be fine-tuning your prompts to be able to handle every possible thing, that agent has to do or that users would demand of that agent to do. That's always, in fact, that's a challenge. I personally have that challenge right now, right? Building, agentic tools, and you find that the prompts that you are putting together, have to be very specific. Well, how specific can you be, right? If you're having prompts and you have, a lot of different, things that you have to essentially prompt the agent to do. How do you manage that? So, it's not very feasible. So you end up having what we call prompt bloat, where you are writing really huge prompts trying to cover every possible scenario, every possible thing that could happen. That's what you are trying to deal with. And of course, it is immediately clear that with prompt bloat, you are going to start having um, high token usage because you are essentially packing a really large prompt into an agent for maybe the task doesn't need all of that guidance or guidelines. But because you want to be able to handle every possible task that that agent can be asked, your system prompt becomes really large. So that's the first one. Then the second problem is that you will have the tool confusion, where you also have a lot of tools being appended or attached to that agent. And sometimes tools may be very similar. And because they're very similar and your prompt is not even helping matters, the agent may end up picking the wrong tools, right? And then you start having reduced accuracy. It is hard to scale. So one giant agent that does everything is not feasible, is not scalable, especially in the enterprise. This is just the same thing as saying one human being should be able to do everything in the world. So it is natural then that you will now do separation of concerns. You now have specialized agents. So you have an agent that does one thing very well, doesn't need to worry about another thing. So in that case, your prompt, you tune your prompts for that specific domain, right? You tune your tools and your tool selection for that agent to that specific specialization that you want it to do, right? And so you have a billing agent, technical agent, whatever, right? Then you have even the router agent. That's its own task. It's also a specialized agent, but its own specialty is to be able to know the right agent to select for a task that the user sends in. So you still have to fine tune the prompt for that. And maybe if there are to be any tool calls, most of the time, router agent will not have any tools because it's not supposed to call tools. It's supposed to basically just choose the right agent, unless it really needs to get more information in order to choose the right agent. So the principle here is the reasoning domain, because the reasoning domain is what determines um, you know, the prompts, the fine-tuning of the prompts, the improvement of the prompts is what determines the tools that you give. Remember, all of these things are contributing to the context window. So having um, specialized agents is a very natural way to scale horizontally because it basically means that for a particular task, you pick the one agent that is fine-tuned for that task. Its prompts will be specialized. Its tools will be specialized. Even the memory and the other aspects will be specialized. Okay. So yeah, so I think we've already seen this. Creating specialized agents are not, it's just the same approach. It's the same way you create an agent. It's the same thing. The only thing that changes is the prompts that you give to it, right? Maybe the tools. So for example, in this case, a billing agent, you've given it instructions, the prompts of how it does that, what it does. The tech agent, what it does. Then the router agent, what it does. Okay. I know the question you ask is, then how then do I know which agent the router agent chooses, right? That's where giving agents IDs, comes to play. Because then you can now tell the router agent if the request is a billing request, then route it to agent with ID so and so, or route it to agent with ID so and so, right? Or you can even have an agent registry, kind of, where agents come and register themselves and with description of what they can do and their ID. Then you turn that into a prompt that the router agent has. and then is able to do the routing. So it's able to classify and then delegate to the current agent by just mentioning the agent's ID. And then you are going to wire all of that up with your own code. So the response or result from this router agent is basically ID of the agent that is supposed to actually handle the call or the request from the user. And then maybe additional information. So this is just a good example of it. Route message. So you're going to call the router agent, you pass the message and let it generate its response. And this response is just going to be the category, right? In this case, it's category. Then you are hard coding it, right? If category is billing, then you call the billing agent. If it's technical, but another more dynamic way would be let it just give the name of the agent. Then you can do validation on that name if such an agent exists. If not, then it will throw an exception back to the routing agent and say, no, you gave us an ID of an agent that doesn't exist. But if the ID exists, then we just call that agent by ID. And Mastra really does that very well because Mastra, you can see that Mastra has IDs in. You can retrieve an agent by calling its ID, right? By simply specifying its ID in the Mastra workspace, right? Now you can just say um, then bracket agent ID, and it will give you that agent, and then you can then call generate on that agent. So that's a very powerful thing, and I want everyone to, take that home because really this year already and in coming years, last year we're not talking about multi agent orchestration. We're not talking, last year everybody was talking about agents, single agents. But now we are talking about multi-agent orchestration. So what that means is that you should be able to write your code that allows you, to do that. Okay. We've already talked about structured output, so I'm not going to repeat this. Basically, we don't use free text anymore if you are, unless you are just taking that output straight to a normal user, right? But these days, if your agentic output typically is actually going to go into a pre-existing system that already has schema and is structured. So you don't want to do free text because of the issues, tendencies you may have. It's hard to pass, extra work to pass, it's error prone and it's risky. So what you do is you force the LLM to generate structured output, and then that structured output will still be validated to make sure that the LLM didn't hallucinate and bring in wrong, structure or wrong data. Okay. So structured output is validated, safe, predictable, and machine readable. And with Mastra, like we've already seen, all you need to do is specify the output and a ZOT schema. And Mastra will enforce this schema on the LLM so that when the agent is generating its output, the LLM must generate output that follows the schema you specified. A structured output, object, category. The category has to be an enum. It has to be any one of these three, nothing more than these three, right? And these are the kinds of structured output that ensures that your LLM generates meaningful response, right? Urgency has to be a number, the minimum has to be 1, maximum has to be 5, and all of that. So you just pass this in when you are creating the agent out along with the other things. And yeah, so that's it. Generate. Then the interesting thing is because Mastra is using a ZOT schema, okay, the rest, and you have specified the output. Mastra is actually going to enforce that the response here, you do not need to check if it contains that schema or if it matches that schema. You can be guaranteed because that's what ZOT does. It's going to guarantee you that the response from the agent will match that schema. So you don't need to do some type checking like this again. As a matter of fact, you will have the type checked for you by TypeScript at compile time. So if you try to even access something that is not in that schema, it will tell you wrong. It is wrong. That's how good Mastra have done this. So effectively, Mastra is so well typed that essentially the agents, the LLMs become just another piece of code, right? Just another um, class that is typed. The response fits the schema that is specified. This makes coding much easier. You don't need to do a lot of this redundancy, defensive checking, but you just depend on it, right? Because you know that if the response that the LLM generates doesn't contain category, for example, the agent is going to kick it back and say, no, this is an invalid output. Try to make it fit, or it's going to try to um, you know, correct it or adjust it so that it fits. So that's it. I think I already talked about model routing, but we can still go over it again. The main reason why you want to do model routing most of the time is managing costs, right? So for tasks that require small models, you use small models at low cost. For tasks that require larger models, you can, especially that is reasoning intensive, you can use larger models, right? Just for that, so that you save your cost. Faster response, you go for a low latency model. And then you can also have fallback. So if a provider fails you, which may happen, you fall back to a secondary provider, and that ensures continuity of your service to your end users. So you have configuration like this, right? Which allows you to do that. And it's very easy to switch. Right now, yeah, we had hard coding names, but you can even make this dynamic, right? And it still works. So this is a good example of how you can do dynamic routing. Select model. Typically, you would take this and put it in the pre before model hook, and you now check if urgency is high, then you can use a larger model. If not, you use a smaller mini model. Um, we'll talk a bit more about middleware, right? You can do logging, monitoring, cost tracking, moderation, and all of that. We'll talk about that next week. Okay. Same thing, guardrails, input filtering. We already talked about that. Profanity filter, moderation, P2 masking, PII masking, privacy information to make sure it doesn't go out, rate limiting. Um, Guardrails will prevent abuse, cost explosion, policy violations. These are examples of how you can enforce rate limiting, right? You can throw rate limit errors. Basically, you keep track of your session limits on a per session basis. And if the number of sessions, for example, exceeds your maximum session limit, then you can have a rate limit error. State machine, we already talked about that. This is kind of helping the LLM to follow a particular reasoning, especially for domain-specific expert things that you don't want the LLM um, to hallucinate. So you guide it with that. And that's it. When we come on Friday, we are going to do the last bit of what we started today, which is assemble all of that together and then maybe have a front end that we will be able to run with a simple Next.js front end that will be able to communicate. Then maybe we'll do a multi-agent orchestration task when we come in on Friday. Then next week, we will deep dive a bit into observability, and we'll look at some of the things we use for observability. We've talked about Langsmith, Mastra. We may also take a little bit of an introduction into Langfuse, and I think that will be that. That's all from me. Thank you. Are there any questions?